Alright, this is the airline load factor data from Department of Transportations from 2003 to 2013. This monthly level data, what you see is, say, January 2003, we have 64.4. What that means is, in January 2003, 64.4% of all the seats, airline seats, in top 100 markets were sold. If you look through this data, what you will see is, what you should notice is, there is a trend in the sense the airlines has become more and more packed, in the sense they have sold more and more of their seats, and also is months like January on average are a lot less sold out than January month like June. So when there is seasonality and trend both, normal techniques like regression or moving average or anything will not give you a very good answer. What you need to do is, we need to first deseasonalize the data, and then you can use any forecasting tools. So let's use the deseasonalization technique that I outlined in the video earlier, and we do step by step. The first step is calculate the sample mean. Well, it's very easy, right? Average all these data sets, and we got it. Let me make this number a little bit readable. 79.44, and I copied all this data, and we can go to the next step here. Right, in step 2, what we do is we calculate the sample average. So the sample average for January is average the January numbers, and we got it. Right, now let's make this number a little bit readable too, and if we pull all the way to December, we get the season averages for each month. Okay, now let's go to the step 3. In this, we are ready to calculate the seasonal factors. The seasonal factors for January is nothing but January's season average divided by the sample mean. Okay, make this number a little readable again. To get the seasonal factor for February, we can't just pull this, because we have to first put a dollar sign here so that D20 is fixed. Now we can pull this all the way here, and we got the seasonal factors for each months. Right now, what this means is that this July, there is 7% more than your baseline numbers. To go to step 4, now the actual step of deseasonalization, what we need to do is we take the January 2003's number here and divide it by the seasonal factor, right? And we can pull this all the way here. We need to fix the column here, just the column, not the row, just R, and we should be good. Make this a little smaller here. So basically, it's equivalent of dividing 64.4 by 0.91, dividing 65.48 by 0.91, dividing 69.77 by 0.998, and so forth. Now for the February numbers, it is the February number divided by February seasonal factor. As I only fixed R, I can just pull all this number down here. Again, what's happening is you're dividing the February number with the February's factor and so forth. You can confirm that here February's factor is divided by R5, right? Alright, the last two numbers is empty, so let me leave this empty. Now if you're using forecasting model, let me use a very simple one. So suppose you are using a moving average of 10. Suppose moving average of 10, then you would take an average. Let me do this outside here. If you're doing the moving average of last 10 months, suppose, for the sake of argument, your forecast here, the deseasonalized forecast would be 82.43, but because this is a November, so we would do your forecast times your November seasonal factor, that is this. So your actual, you expect to see a load factor of 81.55. If you use a different model and come up with a different number, then what you would do is, again, you would multiply by the November seasonality factor. That's all there is to deseasonalization, to add deseasonalization property to your models.